In its natural state, the electrons in a conductor such as copper freely move from atom to atom, but in a completely random way. To get them to move together in one direction, all you have to do is give them a push. The technical term of this push is electromotive force, abbreviated AEMT, or sometimes simply E, but you know it's more common as voltage. A voltage is nothing more than a difference in charge between two places. For example, suppose you have a small clump of metal whose atoms have an abundance of negatively charged atoms and another clump of metal whose atoms have abundance of positively charged atoms. In other words, the first clump has too many electrons and the second clump has too few. A voltage exists between these two clumps. If you connect those two clumps with a conductor such as copper wire, you create what is called circuit, through which electric current will flow. The current continues the flow until all the extra negative charge on the negative side of the circuit has moved to the positive side. When that has happened, both sides of the circuit become electrically neutral and the current stops flowing. Whenever there is a difference in charge between two locations, there is possibility that the current will flow between two locations if these locations are connected by a conductor. Because of this possibility, the term potential is often used to describe voltage. Without voltage, there can be no current. Thus, voltage creates the potential of current to flow. If current can be compared to the flow of water through the hose, voltage can be compared to water pressure at the freezer. It's water pressure that causes the water to flow in the hose. If the current can be compared to the flow of the water through the hose, voltage can be compared to water pressure at the expansion. It's water pressure that causes the water flow in the hose.